So hello everyone, welcome to another particular lecture series of our Reagent Chemistry course, and this is the class 6. So in our previous discussion we are talking about sodium borohydride and its derivatives. So here in this particular class onwards we are starting with some lithium based reducing reagents such as lithium borohydride and selectrides. Okay, so first talking about the lithium borohydride, that it is much more reactive version than NaBH4, and it is a commercially available solid form, and it is also moisture sensitive just like the NaBH4, and it is commonly used for the selective reduction of esters and lactones. Like LiBH4 can do reduction of carbonyl compound, as well as it is commonly used to selectively reduction of esters and lactones, whether the NaBH4 is restricted towards the ketone compound only. Okay, and also the LiBH4 is a very solvent dependent reducing agent, and it is works good with ether, THF and 2-propanols. And here 2-hydride use in this particular mechanism, and it is less hindered side preferred attack hydride attack takes place. So here you can check the example, like here in this particular starting material there is a two functional group. One is the ester functional group, one is a CN a functional group. So LiBH4 selectively reduce ester to its corresponding alcohol, but the CN group are not affected by during this reaction. So functional group tolerance, that LiBH4 doesn't reduce CN, cyano, NO2, amide, carboxylic acid, and alpha beta unsaturation compound. Okay, so here you can see this is the big example where it is our starting material. That starting material contain different type of groups. Here you can see the amide group is there, also NO2 is there, halogen is there, ester is also there. So while treating with LiBH4 and THF, you find that only selectively the ester group is actually reduced to their corresponding alcohol, whereas the other functional group getting intact. So it is a very chemoselective reaction. So what should be the mechanism of this particular reducing mechanism? So here you can find that LiBH4, it is actually first the lithium, it goes chelate with the particular ester group, and due to this chelation actually the electrophilicity of this particular carbon is increased, and that's why this hydrate attack got felicitated. Now this hydrate attack got felicitated, and this particular negative goes back to clip this particular CO bond here to generate this type of compound. Now this particular O minus actually quenched by taking the proton from the solvent itself, so it will generate an aldehyde, and here you can see that OH is there. So but as we know that LiBH4 is actually reduce ester to directly alcohol, so that means that the medium contains the LHBH4 will again transfer hydride here. First it will coordinate with this particular mm, aldehyde oxygen to increase the electrophilicity here, and then this particular hydride attacks to generate this type of intermediate. Now this particular intermediate will take proton from the solvent itself to generate our this type of dihydroxy compound. Okay, two OH is there, one is the primary alcohol, both are the primary alcohol here, and you can find here that two hydrides are actually attached, so that means there is a two hydride actually donated during the reaction. Now let us talking about the superhydride and K and Lselectride. Like this is the similar kind of lithium borohydride, but where this particular H has been replaced by the different R, and depending upon the R group, it actually have different names. Like where the metal, when metal is the lithium plus and the R's are nothing but the ethyl, then it is called a superhydride. But when the R group is sec butyl, when the metal is lithium itself, then it is called the Lselectride. And if the metal has been changed to lithium to potassium and the sec butyl is the R, then it is called as a K-selectride. Now these three reagents have their unique reactivity, so we'll discuss in the next slide. So first we are talking about the superhydrides. Superhydrides are highly reactive reducing agent, Basically, it is done SN2 type of mechanism. It follows the SN2 type of mechanism where this particular RX bond there, when we treat it with superhydride, then what happened that X group is replaced by this particular hydride here, and to form the RH bond. And what should be the X group there? X group should be OH, NH2, OTS, OTF, OBN, and halogens. Okay. So here is a simple example. Here you can find that this particular cage type of molecule is there, which contains CH2 and OTS bond. So what happened that superhydride, the hydride is actually attack here, and via SN2 mechanism, it will generate this particular compound. Okay, and the structure is something like this. Now let us talk about the K and L selectride. It is K and L selectride is nothing but a lithium and potassium trisec butyl borohydrides. And as we know from the structure itself, since it is the R group is the sec butyl, so that means it is a bulky reagent. And it is reduced aldehyde and ketone even minus 78 degrees centigrade. So it is a low temperature. If we go via low temperature based reaction, then also K and L selectride is able to reduce aldehyde and ketone. And it is a stereoselective reagent, and hydride attacks, this particular hydride attacks are from the less hindered sites because of the steric issues. Like already as we know that this particular L selectride and K selectrides are actually bulky in nature, so obviously to eliminate the steric repulsion, they will attack or they will transfer the hydride from the less hindered side of the product or the reactant. Now here you can see the particular example, like this is our starting material, that is alpha beta unsaturated carbonyl compound, and when treated with K or L selectride, we got two different products. One is the 1,2 attack, like here the hydride goes transferred, and in the second case the 1,4 attack, that means here is hydrogen transfer. As we already discussed that K and L selectride are bulky in nature, that's why the bulkiness or the steric factors actually determine that the hydride attacks, where will the hydride attacks goes. Now the 1,2 attack is felicitated when R1 and R2 both are alkyl or aryl. Like if these two particular group bulky enough, then hydride can't transfer from here. That means in that particular scenario, when the R1 and R2 are bulky enough, then only 1,2 addition takes place. Similarly, if the R1 and R2 are hydrogen or kind of small group which contains the less steric bulk, then this particular hydride transfer from the 1,4 position. Okay, so we are actually see this particular trend in this particular following example. Here you can find there is a two different center is there. This is also 1,4 additional place, and this is also 1,4 additional place. Now here you can find these two particular are bulky group. That means hydride transfer become much more sterically hindered in this particular center. So here it will not actually uh, uh, not attack from this particular center, but whereas that here you can see this is also alpha beta unsaturation position, and this particular 1,4 position you can find that two hydrogen is there, that means the less steric bulk is there, so it will initially attack from here, this particular bond goes there, and this got a negative charge. Now in the second case you can say the ethyl iodide is there, so that means what happened that I am just changed the ink color. So this particular negative charge go back, and here the partially the double bond has been formed here. This particular double bond that actually attack here to eliminate the iodine, and finally we got this particular product exclusively. So that means we can say that it is a regioselective regioselective pathway has been followed here. So it is written here that is the less hindered side is a more sterically hindered center, and that's why this type of reaction actually felicitated. So with this we have to end this particular class. So I hope you have understand about the lithium borohydride and the superhydride and K and H selectride. So in the next lecture we are talking about some more reducing reagents such as zinc borohydride and lithium aluminum hydride. So thank you for listening.